Hi, my name is Vincent, and today I want to take you all through the AP Calculus AB 2008 multiple choice calculator section. So we're starting at question 76 here, and we have a graph of f prime, the derivative of f, on the interval from -2 to 5, and we want to know where f is increasing. So for this question, all we're looking for, if we're looking for where f is increasing, is we want to identify where f prime of x is greater than 0. So for the calculator section, you don't always have to use it. So, don't try to use it for every question because that might slow you down. So if we're looking for where the graph of f prime is greater than 0, we're looking for the parts where the graph is above the x-axis, which is going to be in this section here. So this part of the graph and also this part of the graph over here. From 3 to 5 is no good. Now this question was a little bit sloppy because the technical answer should be all the x values from -2 to 1, union the x values from 1 to 3, because when the derivative is 0, the function f of x is neither increasing nor decreasing. But it looks like in this case here, the closest answer is going to be choice B. So in this case, they're including the endpoints and the zeros, but once it's a sloppy question. This is a better answer, the one I have written here, but we're going to go with choice B. For question 77, we have the graph of a piecewise function. The domain is 0, x is between 0 and 4, and we want to know which statements are true. So statement 1 says the limit as x approaches 2 from the left of f of x exists, which it does. Let's say I call this value a and I call this height down here b. The limit as x approaches 2 from the left would be equal to a, and the limit as x approaches 2 from the right side, if you can't see that, there is a plus sign here. So approaching 2 from the right side, this limit is equal to b. So as we approach from the right, you see how we're heading to a y value of b. So this one is also true. So we have 1 is true, 2 is true, but this is not true because in order for a limit to exist, the left limit has to be equal to the right limit. And as we could see from 1 and 2, the left limit is approaching a height of a and the right limit is approaching a height of b. So since they're not approaching the same height, that means the limit does not exist. So in this case, it's only 1 and 2 that are true. Now for question 78, we have a derivative sine of x cubed minus x, and we want to know on which intervals is f of x increasing. So for this question here, we're looking for where f prime of x is greater than 0. So we're just going to use the calculator for this question. So we're going to type in the derivative, which is sine of x cubed minus x. A few things. Make sure you're in radians, which we are. It says it right here. And we're going to make the window, we're going to adjust the window to go from x equals 0 as our minimum and x equals 2 as our maximum. Whenever they give you an interval, it's usually a good idea to make that your x min and x max. So now when we graph this, notice what we're looking at here. Well, what we're looking for is when is the graph of f prime greater than 0. If you want to get a better picture, you can make your y minimum and y maximum like a little bit closer together. So we could do like, let's say -3 to +3. And this should make the picture a little bit better. But it looks like it's crossing at x equals 1 and somewhere around 1.5. But this is where the tracing feature is going to come in. But the interval where our derivative is positive is between 1 and some other number around 1.5. So right away, we could eliminate the answer choices C because it doesn't start at x equals 1. D is out because that doesn't start at x equals 1, and there's 2 intervals. We only have 1 interval here. And choice E is out because, once again, we only have 1 interval in our answer. So it's either A or B in this situation. But now for the accuracy, we're going to trace. Second trace 5 brings up the intersection. I'm sorry, we're going to do second trace 0. We're going to trace the root because that's going to tell us where the derivative changes from positive to negative. That's going to be at this location here. And see how our y value is slightly positive? It's like 0.28. hit enter once, and then scroll to the right until the y values turn negative. Hit enter a second time. We hit enter a third time, and it looks like x equals 1.691 is the x value where the derivative changes from positive to negative, which corresponds to choice B. That's for like full accuracy, we're going with 1.691. So choice B for question 78. For the next question here, this is a no calculator question. I wouldn't waste your time trying to use a calculator here for this. We want to know the value of the integral from -5 to 5 of f of x, and we have these two known integrals here. Now, this one is good to go, the first one, but the idea is that if we want to find the area from -5 to 5, what we could do instead is find the area of the function from -5 to 2. So we find this area, and then we're going to add it to the area from 2 to 5. So looking at these integrals, this given integral here, we should switch around. We're going to flip the limits from 2 to 5 because it should be in order from least to greatest. The lower limit should be smaller and the upper limit should be higher in order for us to add these two integrals together. So we got the integral of f of x dx from 2 to 5 is going to be equal to +4. Because remember, when you switch the limits of integration, it changes the sign of the integral. So now this will be +4. So then to answer this question, all we have to do is we have the integral from -5 to 2 of f of x plus, well, I'll just drag this, no point in writing it twice, plus this integral over here. And now that's just going to be equal to, this one is equal to +4, and the other integral, -5 to 2, is equal to -17. And this is going to result in -13, which looks like choice B. So 79, we're going to go with choice B. For question 80, we have the derivative of f written here, and we want to know how many points of inflection f has on this open interval. So in order to find points of inflection, what we're really trying to find here is a sign change in f double prime. Now, the really time-consuming way to do this would be to actually use the product rule and chain rule to find the second derivative and then find the zeros and all that. But considering you're in the calculator section, there is a fast way to do this. What we could do is just type in f prime of x, and we want to find f double prime of x, so we're going to take the derivative of f prime using the calculator. So we're going to write math, option 8 is derivative, and we put the x variable in because our function is going to be in terms of x, and now we just write in x squared cosine of x squared. But then for this part, for the x equals, we're going to write in x equals x. And what this is going to tell the calculator is it's going to tell it to graph the derivative of f prime. And then the next thing we should do is make the interval go from -2 to 2. And we had the y min and max at -3 and 3, and we'll leave it at that. Because, like I said a moment ago, all we're looking for is where the second derivative changes signs. That's when the graph of f double prime changes from positive to negative, or from negative to positive. So when we press graph, we just have to count how many times it passes through the x-axis from negative to positive or vice versa. So we have 1. So far we have 2 changes in signs. There's a third one at 0. And let's see how many more. We have a fourth one at this location. And let's see if we get another one out of this. And yes, we have 5 total. So we have 1, 2, 3, 4, 5 locations where the graph of f double prime changes signs. So that tells us we're going to have 5 points of inflection on this interval. So for 80, we're going with choice E. For 81, all we're told here is that capital G of x is an antiderivative of f, and we have g of 2, and we want to find g of 4. So in a situation like this, if g of x is the antiderivative of f, we'll set up the expression, the integral of f. And it looks like in the answer choices, they're going to re-index this. They're going to call it the variable t. So I'll just start that over. We'll say the integral of f of t dt, we know what g is at the value 2 here, so we'll write 2 as our lower limit, and we want to know what g of 4 is, so that's going to go in our upper limit. So then here, the concept is, what we're using is FTC part 1. We're using the fundamental theorem of calculus, and the way that works is, to evaluate this definite integral, we do the antiderivative, which they told us was g, and then we evaluate capital G at the upper limit, we evaluate it at the lower limit, and we subtract those two. So that's why this expression is showing up in the answer choices. So then this is just going to follow this line. We have the integral from 2 to 4 of f of t dt is equal to g of 4, which is what we're trying to find, and then minus negative 7, which will change this to plus 7. So then if I want an expression for g of 4 is equal to negative 7 plus the integral from 2 to 4 of f of t dt. So for 81, we have choice E is going to match what we have here. For question 82, we have a particle moving along a straight line, and we have a function for velocity, 7 minus 1.01 to the negative t squared. And we want to know the acceleration of the particle at time t equals 3. So for this question, if you want to know acceleration at time 3, that's acceleration is equal to the derivative of velocity. So what we're really finding here is v prime of 3. So once again, this is the calculator section, so we could just type everything into the calculator. We're going to press math 8 to do derivative. And we could write it in terms of x, even though the question is in terms of t. And the function is 7 minus, and we have 1.01 raised to the negative t squared. So we'll put negative x squared power. Okay, and then we are evaluating this derivative at t equals 3, so we're just going to write a 3 in this location. So when we write this to the nearest thousandths place, we're going to get 0.055. So this is 0.055, which is going to match choice B for question 82. All right, so just know for a lot of these questions in the calculator section, like you could take this derivative by hand, but it is very time consuming, so you definitely want to make use of the technology as often as possible. Now for question 83, we're finding the area between two curves, and we have one function here. Well, we have two functions, so we're just going to go ahead and type those in. So we've got x to the third minus 8x squared plus 18x minus 5. All right, so that's our y1, and then for y2, we have x plus 5. So when we graph this, I'm going to hit zoom 6 just to put this back to normal, because we did adjust the window a bit before. And let's see what this looks like. So we have the cubic function first, and then the next one is linear. Now, since everything is going on in quadrant 1, what we could do with the window is we could set the x minimum to 0, x maximum 10. We could do this same thing. Well, the y minimum we can make 0, and then maybe the y maximum will make it go a little higher, because that way we could see all of what's going on here, because it looks like there was like a little bit more to the graph above. So the area enclosed by the curves is referring to the area between this part of the function and the red line. So we have the curve in blue and the red line, and then this area here, this red line and this blue curve. So what we're looking for here is the points of intersection. Now you could trace them, but sometimes it's easier to just look at the table because it looks like they're intersecting at whole numbers. So if I press second graph, you see how when x equals 1, y is equal to 6 for both equations. That tells us that one intersection point occurs at 1, 6. The next intersection point occurs at 2, 7. And then the third intersection point occurs at 5, 10. So if we look back at the graph, to find this area, what we're going to evaluate is the integral from, and remember, when we're integrating in terms of x, we're going to pay attention to just the x values. Like we're, I'll do this in a different color so it stands out. We're only looking at the x values because we're doing the integral in terms of x. So then in the first section here, the first equation, it looks like, and I'll name these over here, we'll call this one y1 and y2. It's the integral from x equals 1 to x equals 2 of the top function minus the bottom function. So we're going to write, we have y1 minus y2 times dx plus, but then in the second region, the line y2 is on top. So then our next integral, the roles reverse, and we have y2 minus y1 times dx from x equals 2 to x equals 5. So when we go to the main screen, we could write this all in. We have math 9 is going to pull up a blank integral, and we're doing the integral from 1 to 2. And to save time, I could hit the VARS button, hit the right arrow, enter on the function, and I'm doing y1 minus, and then for y2, same thing, except this time I'm choosing option 2. And then it's dx. So the first integral works out to 0.583 and a continuing 3. So then I'm going to add that to the second integral, which is math 9 from x equals 2 to x equals 5. But this time around, we have y2 minus y1. So y2 minus y1. So when we add all of this together, the sum of those two is going to be 11.833, which corresponds to choice B. Now, because in this question the regions were attached to one another, we could have just done one integral from 1 to 5 and put y1 minus y2 or this one in absolute value, and it would have given us the same answer. But we could write it as two separate integrals as well. For question 84, we have a graph of f, and I'm sorry, we have the graph of the derivative of f above. So this is a graph of f prime. So we're looking at the derivative above, and they're telling us there's horizontal tangent lines at x equals -1, x equals 1, and there's another one at x equals 3. And they're asking us to look for the value of x for where f has a relative maximum. So the moment you hear this phrase, you should automatically think first derivative test and say we're looking for where f prime changes from positive to negative. But since we have a graph of f prime, we're looking for where the graph goes from over the x-axis to under. So we're looking for where we go from over to under the x-axis. So if we look, see how we have a root here, but this is us going from under to over. So this would be a relative minimum. This wants to be a relative maximum, but because the graph goes back over, it's just a, it's a place where the slope is equal to 0. And it looks like the only place where it's going to occur is here at x equals 4. At x equals 4, the derivative changes from positive to negative because we're going from over to under the x-axis. So for 84 is going to be choice C here. The horizontal tangents were just a distraction for this question. You really just needed to know where, at which root you change from positive to negative. So sometimes they volunteer extra information to try to confuse you. So just, try to sort through that stuff. For question 85, we are looking for the value of this definite integral. And they're telling us f prime is continuous on the interval from -4 to -1. So to evaluate this integral, we're just going to use FTC part 1. And just think that the integral here is equal to, by fundamental theorem of calculus part 1, all we have to do is take the antiderivative of f prime, and the antiderivative of f prime is equal to f of x, and then we're going to evaluate from -4 to -1. So this is equal to f of -1 minus f of -4. So all we have to do to complete this is we're going to look at the table. F of -1 is -1.5, and we're subtracting f of -4, which is 0.75. And this works out to negative 2.25. And that's going to match choice B. So we have 85 as choice B. Okay, for this question here, we have a table of values for velocity, and we're asked to determine like which graph could represent a graph of the position function. So the relationship here is that we have a graph of position functions, but the velocity tells us the rate of change or the derivative of position. So one way to go through this question is to look, and this point jumps out at me right away. This is telling us that the slope of x of t is 0. So is 0 at t equals 3. So if we look at some of these questions, or some of these answer choices, you see how here at x equals 2, the slope is equal to 0, so choice A is out. So 86, we're not going to go with A. Now for this graph, same idea. The slope is not equal to 0 at 3. The function value is equal to 0, but the slope is negative here, so this one is out. Then if we look at this graph, the slope is equal to 0 at 3, so this one is still in the running. And if we look at choice D, the slope is equal to 0 at 2. So just that one value alone eliminates 3 choices so far. And then here, we have for choice E a 0 slope at this location. So then if we look elsewhere in the table, let's say we try this value. We're going to try another value out to see if it eliminates one of the remaining answer choices. So this is telling us that when t is equal to 1, the slope of the graph is 2. So at t equals 1, we're on this part of the graph, and we have this slope of positive 2. So this one looks like it could still be it. But then when we look at this answer choice down here, you see how at this location, this is like almost a 0 slope. So we're going to cross off choice E here and say choice C, because the slope of a slope of 2 is more visibly accurate here for choice C than it is for this one. If you wanted to choose another point to verify, let's say at 4, it looks like here we have like a steeply decreasing slope, whereas at this one at 4, it's almost like it's approaching like going straight down at this location. So this one is like also not as accurate as choice C. So for 86, we're going to go with choice C. Now for this question here, we have another particle or an object moving. So it's like a position velocity type question. And we have the initial position given to us. And the velocity function is given here. And we want to know what is the position of the object at t equals 3. So if we want to know basically what x of 3 is in this question. So what we're going to do is we're going to look at the integral of v of t, and the limits we're going to use are 0 and 3. Because once again, if we use FTC part 1, the antiderivative of velocity is position, and then when we evaluate it at the limits, it's going to be x of 3 minus x of 0. So then x of 3 is equal to initial position, so we're going to add x of 0 to both sides. So we're going to have 2 plus the integral from 0 to 3 of v of t dt. So the rest here is all calculator work. We're just going to type that whole phrase in. So 2 plus, we write math 9 to pull up a blank integral. We're going from 0 to 3. And v of t, we have a cube root function, so that's math 4. Or you could always write a 1/3 power if you want. And then we have 1 plus, we're going to write x squared instead of t. And now looks like that's it. And then dx. So this works out to 6.512. And that's going to be choice D. Now for these questions, if you were going to try to do this antiderivative by hand, this is something that you can't do with U substitution. So it's really important that you learn how to use this calculator well for this section, because they will give you something that can't be integrated by hand and that you have to use technology for. So for question 88, we have a related rates question. So start defining variables when you read these. We have the radius is decreasing at a rate of 2 centimeters per second. So I'll just label that right away as dr dt is equal to negative 2 centimeters per second. And now we have at the instant when the radius of the sphere is 3 centimeters, so we're looking at r equals 3 centimeters. We want to know what is the rate of change in square centimeters per second of the surface area of the sphere. So we'll call capital S surface area. We're looking for d s dt at, and are we given a specific time? At r equals, all right, so we're going to evaluate this at r equals 3 centimeters. So we're looking for what is ds dt when r is equal to 3 centimeters. So the primary equation that we're going with here, the surface area of a sphere is 4 pi r squared. And we're going to take the derivative of both sides with respect to time. So we're going to do d over dt of both sides. So that on the left, we're going to get ds dt. And on the right, it's kind of like we're using the chain rule here. We're going to have 8 pi r when we do the power rule on r. But the derivative of r with respect to time is going to tack on this extra dr dt. Don't forget this piece because it will definitely throw off your answer. So then here, to evaluate this, we have capital ds dt at r equals 3 centimeters is equal to 8 pi, and now we have 3 centimeters times dr dt, which is negative 2 centimeters per second. So once we work all of this out, this is negative 6 times 8, which is negative 48. We have the pi attached, and then centimeters times centimeters a second is centimeters squared per second. So it looks like for this one, we're going to be going with choice C, negative 48 pi, and the units are square centimeters per second. For question 89, this is a question involving the ideas behind Rolle's theorem. So we're looking at Rolle's theorem here. And the three conditions of Rolle's theorem is that you have to have a continuous function, which for question 89, they tell us that f of x, let's just make that a little neater. They tell us that f of x is continuous. So the first condition is met. The next condition that's met is that the function is equal at the endpoints of the interval that we're talking about. And in this case, f of negative 2 is equal to f of 2, which is equal to 0. The third case of Rolle's theorem is that the function is differentiable. So I'll just abbreviate that here. And if those three conditions are met, then there is a c value on the interval from negative 2 to 2 where the slope of the function is equal to 0. So if I were to just draw a continuous and differentiable function here, see how this would be the location where my derivative is 0. But in this question, they're saying there is no c value. So which of the following statements must be true? Well, since the first two conditions are definitely true, that means we're going to look for an answer choice where basically the function is not differentiable from negative 2 to 2. And you see that's going to match up with choice E here. For some k value between negative 2 and 2, the derivative does not exist. So what that looks like, if we just drag this out, if the derivative doesn't exist at some place, well, that just means that if we were to draw this function, is that at some point we're going to have a sharp turn. So the graph is going to have a sharp turn, which would make it that the derivative doesn't exist at some value k. The reason why, and we'll go through the answers here why these are wrong. They're saying for choice A that what has to be true is that the derivative is always positive. But if the derivative was always positive, that means this graph would always go up, and it would never be able to come back down and make f of 2 equal to 0. So this one is out. Choice B is out because it's saying something very similar, except this case they're saying the derivative is always negative, which means the function is always decreasing. So it wouldn't be able to make its way back to make f of 2 equals 0, so this one's out. And what they're telling us for choice C is that for the open interval, the derivative does exist. But if that were true, then Rolle's theorem's conditions would be satisfied, and there would be a value C where the derivative is equal to 0. So this one is out because Rolle's theorem is not satisfied in these given conditions here. And for choice D, it's repeating this concept, so choice D is also no good for the same reasons that choice C was no good. So choice E for 89. Now for question 90, this question was definitely a bit tricky. So really focus in here. We have a table of values for all these 5 answer choices. We're told that f is a continuous function. It's twice differentiable, which means that there's no issues with the second derivative on the open interval. And we're told here that f prime of 3 is equal to 2. And we're also told that the second derivative is always negative. So what that means is that f prime of x is always decreasing. So this is strictly decreasing f prime of x. And f prime of x, remember, is the slope of f of x. So the idea behind this question is we want to analyze the slope. And we want to know which of the following could be a table of values of f. Well, what we want to focus on here is if I were to draw, a rough sketch of a graph. If this graph has a second derivative that's negative between 2 and 4, that means the graph from 2 to 4 is concave down. So it's going to take on this shape here. And what we're told is that at x equals 3, the slope of the function, so the slope here is 2. So we have a slope equal to 2. But since the derivative is always decreasing, one of the ideas we're going to make use of is that here, we're going to say the derivative is greater than 2 before x equals 3, and after x equals 3, the derivative is less than 2. So that's the idea that's going to help us answer this question. Now I'll go ahead and spoil it and say 90 is choice A, but first I just want to explain why these answer choices are wrong, and then we'll be able to see why this one is definitely right. So the idea is if we're analyzing the slope, we're going to find the average rate of change from x equals 2 to x equals 3. So all we have to do is subtract the y values and divide by the difference in the x values. And if we do that here, so for this question, we're going to do that. Let's make that a little bit neater. The difference, 5 minus 3.5 is 1.5, and then divided by 3 minus 2 is 1.5. But think about what we just said a moment ago. If the slope has to be greater than 2 before x equals 3, on this interval here, if the average slope is 1.5, there's no way this could be choice E. And furthermore, if we look from x equals 3 to x equals 4 on this interval, the average slope, if we do 7.5 minus 5 divided by 4 minus 3, the average slope is 2.5, but we said the slope has to be less than 2 after 3. So once again, E is out. Choice D is no good because if we look here, the average slope is 2 and the average slope is still 2. So the average rate of change is not decreasing, and we need the slope to be decreasing. And also we said before x equals 3, the slope has to be greater than 2, so the average can't be 2. So for that same reasoning, choice D is no good. And if we look at this one here, the average slope is 2, and here the average slope is 1.5. Now this one is fine. We said that the slope should be less than 2 after x equals 3, but this one is no good. If the average rate of change of f of x from x equals 2 to x equals 3 is 2, and the slope is always decreasing, there's no way that we could have a slope exactly equal to 2 at x equals 3. So C is out. If we look at this question here, the slope, or the average slope from, let's just fix that. The average slope from x equals 2 to x equals 3 is 2.5. So we start off, okay, we have a slope that's greater than 2. But the part that's a problem here is that the average slope from x equals 3 to x equals 4 is equal to 2. We need it to be less than 2, so that's why B is out. And if we use that reasoning here, you'll see that the average slope from x equals 2 to x equals 3 is 2.5 when we subtract the y values and divide by the difference in the x values. And then the average slope on this interval is 1.5. So this is the only one that could work because the average slope here is greater than 2 and the average slope after x equals 3 is less than 2. So choice A. Now for this question here, we're going to go back to using the calculator. We want to know the average function value of y equals here on the interval from -1 to 3. So what we're using is the formula 1 over b minus a. So we have 1 over 3 minus negative 1. The integral from a to b of the function, whoops, let me just fix that. That's a little sloppy. Should be multiplied by. So we're doing this fraction here. Oh, this is all connected. But we're doing this thing times the integral. So what we're really going to tell the calculator is 1/4 the integral from -1 to 3 of the function given to us. So 1/4, we could just write 0.25, and we're writing in math 9. And we're going from -1 up to 3. And that's a lot to write in the denominator. There's this way of writing fractions. If you press alpha y equals enter, it pulls up a blank fraction, and we got cosine x in the numerator, and then we got x squared plus x plus 2 in the denominator. So we'll just type that in, and then just scroll to the right and put an x, so it says dx in the integral. Now when you hit enter, it should give us our answer, which is 0.183. So we got 0.183 for question 91, and that corresponds to choice C. All right, for question 92, we just have to be really careful how we think about this one. These questions could be a little annoying, but we have a city, and they have a rectangular boundary around the city. We have a river on this side here, like to the west, and they're giving us the dimensions of the city. It's 4 miles wide and 7 miles long. And what they're telling us is that the population density at any point along a strip X miles from the river's edge. So if I'm X miles from the river's edge, that means I'm going like X units in this direction. So the strip is going to be vertical, corresponding to this diagram here, because this strip is X units away from the river, no matter which location I look at. And what they're telling us is that the population density is f of x, persons per square mile. So if I were to take this strip out, we take it like out of the shaded region here, this small change in the x direction we call dx. The vertical distance is constant, that's 7 miles. And then we're treating this as a density problem here, so which is kind of telling us like the thickness of this. And they're telling us that we're going to call that f of x. So the idea, if we want to find population, remember the idea of population is that density is equal to population like over a given volume or area of land. So the population, we're going to be doing the density times the volume or area. In this case, it's more of an area concept, like 7 times dx. So that means to find the population, we just multiply these things together. And the slice of population for this single strip we could call dp, and that's equal to 7 times f of x times dx. But for the whole population, that's where we're going to do the integral and add up all of these slices. It's like a Riemann sum concept. So we're doing 7 times the integral of f of x dx, and we have to think, well, how far do these slices go left and right? They go 4 miles. So that's why we're going to go from 0 miles out to 4 miles for this question here. And that looks like it's going to match up with choice B. So 92, we're going with B. Okay, well, this is going to conclude this AP Calculus review, the multiple choice with the calculator section. If you found this video helpful, please click on the like and subscribe button below. And if you have any requests, leave it in the comments section. And thank you all for watching.